Good morning, gamers. Welcome into the Jarcode channel. So we want to make Pong. In order to make Pong, we're going to need two things. First, we're going to need Python. Then, we're going to need some sort of integrated development environment, or IDE. If you already have one or both of these things, feel free to skip ahead to the coding tutorial. I'm going to go ahead and install everything fresh. So we're just going to search for Python, and here it is, Python. We're going to go ahead and download. I'm on a Windows computer. We're going to scroll down. And right down here in Files, we have your Windows operating system. We can go ahead and click on Windows Installer 64-bit. You probably have a 64-bit computer. And we're going to click on that because, it's recommended. And open that up. Bloop. Okay, great. Yes, we want to use admin privileges. And very important, yes, we want to add python.exe to path to install now. This will just install it to your computer. Me personally, I'm going to choose a custom installation. My computer has pretty much 5 gigabytes of memory and I need to put it onto an external hard drive. And okay, setup was successful. That's great. That means Python has been installed on my computer and on your computer as well. The IDE we're going to be using is Visual Studio, because who doesn't use Visual Studio nowadays? So we can just type in VS Code, click on download. Download for Windows, blop, and it automatically starts downloading up here in the top right. Look at that thing go. Wicked fast. We'll go ahead and open that thing up and run it. Yes. This, again, you can leave this exactly as it is. It'll download right to your C drive. There we go. Look how organized this is. Okay, I'll do next. Yeah, that's fine. We can make a start menu folder. That's totally fine. Yeah, we can make a desktop icon. That's cool. And add this to path. That's important. This stuff, yeah, you can leave it unchecked. It's fine. Whoa. Okay, we don't need to launch Visual Studio just yet, but we can go ahead and finish. There we go. Easy as that. We have Python and Visual Studio downloaded. Okay, now all we need to do is install the Pygame library using one simple line in our command prompt. Easy way to get to command prompt is look at the bottom left of your keyboard if you're on Windows. Go ahead and press that Windows key and R as in run. This opens up the run window. Right in here we can type in CMD and hit enter. Okay, we're going to call py, which is short for Python, dash m space pip install dash u pygame dash dash user. Hit enter. Now it does say that a new release of pip is available. Is it a good idea to update this? Yes, it is. So it gives us the command right there on the screen. We're just going to literally copy and paste that, which we can do by clicking, dragging, Control C, and then right clicking, pressing enter. Okay, we have the latest version of Pygame installed. That was great. We can close out a command prompt now, and we can open up a little thing called Visual Studio Code, which we should have on our desktop. Let's go up here to File, and make a new file. The file, let's call it Pong.py, so that Visual Studio knows we're working in a Python file, and we'll hit enter again. Now we're going to choose where to save it. I currently have a folder in my G drive called PyScripts where I'm just saving, Python files. Make sure there's the .py and that it's saved as all files. You can save this wherever you want. I'm going to hit create file. Yes, that's fine. The very first thing we're going to do is import the Pygame library, the entire thing. To do that, we're going to say from Pygame import space asterisk. This is taking the Pygame library and importing everything in it. That's what that asterisk means. Cool, we can space down a little bit. Now we want to set up constants. Constants are normally in code, they're going to be depicted in all caps because they're infallible. They're never going to change. So we can make a comment here with hashtag or pound constants. It's always great to document your code, right? Everyone loves it. Okay, so let's go ahead and define what our screen width is going to be for this window that we're making Pong in. So all caps, screen width equals, let's set it to 900. This is going to be 900 pixels. Then we're going to say screen height, which we're going to set to around 600 pixels. This is cool. This is epic. And these are just variables that we're setting here. It could be anything. This could be x equals 10,000, y equals 0, you know, making crazy windows. But we haven't actually made the window yet. This is just a variable that we're going to use to plug into something later. But it's good to define it. We're saying, let there be light right now, is what we're saying. Let's set the background color. We can say BG color for shorthand. That's going to equal, in parentheses, but this is the red, green, and blue values that we're going to use to mix colors in order to make one color. I want my background color to be black. The RGB value for black is 0 red, 0 green, and 0 blue. You can look up RGB values for any color you want and put it here for the background. The player 1 color. So player 1 underscore color, because in programming there's no such thing as spaces apparently when you're setting variables. Let's make player 1 blue and player 2 red, because red versus blue is a classic like Halo thing. So the blue value in RGB is 0 0. Can you guess? 255 player 2 underscore color. Now this one's going to be red, and you can already infer what this is going to be. It's going to have a red value of 255, and everything else is going to be 0. Alright, now the only other color we need to define is the ball color. Alright, get your head out of the gutter. This ball color is going to be white. Now, this is a little fun. What happens when we mix every color ever? Well, we probably get black, but we actually get white. So, yeah, I don't know, I'm not a color theorist. This is just how it works. 255, 255, 255. We're going to draw these to the screen. Before we draw these to the screen, let's go ahead and make a function, because functions are super useful when we're learning programming. To make a function, the very first thing we do is type these 3 little letters. DEF. Insane, I know. Then we define our function name. Our function name can just be draw underscore objects. Oops, whoops, whoops. Oh no. Objects. Okay, draw objects. Parentheses. Colon. Under this colon is where the function is going to happen. As you can see, your IDE will automatically do the indentation for you. Look at that. Isn't that beautiful? You don't even have to press tab or space or anything. Wow, that's awesome. Okay, now we're going to call upon a built-in function within Pygame. This function will draw to the screen objects, which is what we're defining. So it's going to be a series of objects. First, we're going to draw a little rectangle for our first player's paddle. So let's say draw dot rect. Okay, this draw dot rect is going to take in 3 arguments. First, where is it drawing to? Screen, comma, space. we're going to go ahead and insert our player's color. This is the RGB value that we put in for player 1. So that's going to be player 1 underscore color. Great. Then we're going to go ahead and define this as a new thing. Player 1 paddle. Okay, cool. So that's a little weird. Like, where did P1 paddle come from? It's not defined. It's not defined anywhere. We'll define it later. But this is what we're setting up in the draw objects function. Keep going. It'll make sense in a second. Okay, cool. And player 2 paddle. Draw.rect. Same values, only we're going to replace this with player 2 instead of player 1. So we're drawing it to the screen. Player 2 color. Whoops. Color. Player 2 paddle. Then, the next thing we need to draw to the screen is going to be the ball. So we'll say draw.rect. Wait. This is a ball. Balls aren't rectangles. They're circular. So instead, we're going to use draw.ellipse. This tells Pygame to draw an ellipse on the screen. Great. I'm going to take that to the screen. We're going to insert our color. And we're going to call this ball. We just wrote a function that will draw to the screen pretty much all of our moving parts and variables, even though some of these parts haven't been defined yet, such as screen and our paddles and the ball itself. All we have so far, but that's okay, because the very next thing we're going to do is space down here. We're going to backspace to get out of that function, because we don't need to be in that function anymore. And then we're going to set up the screen. Okay, it's time to define this variable that we set. So let's say screen equals. Automatically that squiggly line went away, because finally it's like, yes, you're defining this. We're going to use another Pygame built-in function. This is called display.set underscore mode. Okay, display.set underscore mode is going to take in two variables, the screen width and the screen height, which we already defined in our constants. Everything is coming together. So, in order to call the function, normally we're going to have to make the little parentheses here. But we're also going to input two parameters into this function. So that means we need the double parentheses. Then we'll enter screen width and screen height. Okay, great. The screen, it's set up already. This is epic. We're going to set the caption for the window that's going to be displayed in with this display.set underscore caption. Okay, we'll go ahead and make the parentheses. And this is going to take in a string argument. This string is going to be called Pong game or whatever you want to call it. You can call it whatever you want. Great. Okay, the screen has been set up. What font do we want to use to write this screen of the text? Because you got to choose your font. Python has a built-in function yet again. Font.init. We turn to Britain for a little bit, and we say font.init. Comic Sans 35. is what we're going to call this font. You can call this whatever you want, by the way. You can say, hey, hi, yo, equals. You can say that. But we're going to say Comic Sans 35 because I'm going to use the font Comic Sans in the point value of 35 for this project. In order to get that, we're going to assign it to font.sysfont. There's that parentheses again. Remember, we always use parentheses when we're calling functions, and then we input the parameter. The parameter is we're going to select the font, and then we're going to say, how big do we want this font to be? We want the font to be 35 points, because that's like a good size for this window that we're making. We're going to use Comic Sans MS. Let's document what's going on. Selecting font. Let's space down a little bit. Okay, we're going to go ahead and initialize some player values. Player values are essentially what's the paddle width, what's the paddle height, what's going to be the Y position of these paddles, and then we're also going to set up a little bit of a point system because we need to know who gets what when they score, keep track of everything. It'll be great. All of that's going to be done right here under the player value section. Alright, so the first thing we want is paddle width. We can name it like this and set it equal to, let's make it about 30. This is going to be 30 pixels. Then we're going to say paddle height. Let's say that's around 100. That'll be good. Okay, now we need to set the Y position for player 1. This is where player 1's paddle is going to spawn into the window. So let's say P1Y. Let's set that to about 250, because that's where it's going to be good for this window. And for P2, let's also set that to 250. This will make more sense in a moment once we can visualize it. Okay, then we're going to set up the points. So for player 1 points, we're going to go ahead and start both of them at 0, 0, because that's fair and square. Player 2 points, 0. Okay, great. We've defined the player values. Now we need to go ahead and set up the ball coordinates and the ball speed. Because the ball, it's going to be moving and it's going to be angry. So we'll say define the ball. Cool. We're defining the ball now. So let's say ball X. This is going to define the X coordinate of where the ball is going to spawn on the screen. Let's set that to 450. Ball Y, Y coordinate. Oh no, you've sunk my battleship. 450, 300. Right there, dead in the middle of the screen. Of the window. The window of the screen, you get it. Okay. Ball DX. What does DX mean? It's going to be our notation for the ball's speed. We're going to go ahead and say in the x-axis, it's going to move at a speed of 4. And then in the y-axis, it's also going to move at a speed of 4. No, we haven't actually set anything yet. All of this is hypothetical. It's floating around in space. We haven't constrained it to anywhere yet. But we will with the game loop. The game loop is the core of everything that's going to be happening in this Pong game. And congratulations, because we've just defined everything that we need to run this game loop. This is it. Game loop. So a game loop is pretty much always going to be a while loop. So we'll go ahead and set running as a Boolean to equal true. This is just a variable that we're setting that's going to enable us to run this while loop. It's going to say while running equals true. We're going to run through this code. Also, we're going to set up another function called myClock. The myClock function is essentially going to set the frame rate of this game. Okay, while running, we've created the while loop, while running, colon. We're going to press enter. Inside of this while loop, we're going to say for. We've already got a nested loop, so this is a little complicated, but everything's going to be okay. In this for, we're going to go ahead and listen for something. We want to listen to an event. So let's call this EVT in event.get. Event.get is another built-in function, you guys, but we do have to put another colon. So we're listening for an event in event.get. If the event.type has an absolute value, which is denoted as equals equals, quit, we're going to set running to false. We just activated a core component of the while loop. First, we set running to equal true. And we said while running is true, we're going to run all this code unless this happens. This is a handling exception. If an event happens such that your mouse hits the X on the application and the application quits, we're going to stop running this code. So remember, we are still in this while loop. So we want to press enter here. We want to press enter again. And now we want to be in the same area as our for. So if you look at this line here, it will tell us what's inside of the for loop and what's inside of the while loop. We want to be inside of this for. So let's backspace 2 times. Okay, now we're exactly where we need to be. 2, update the player positions. This is going to allow us to move our paddles up and down on the y-axis. So let's call this paddle movement. Oh no, looks like it put us back into the if. We don't want to be in the if. We want to be in the for. Okay, we're back in the for. We're going to listen for something called keys. Keys. Great. So keys are going to be equal to key.get_pressed. This is yet another built-in function into Pygame, so don't even worry about it. Press enter. We're going to make an if statement, because if the keys on the keyboard, these keys are going to be, let's see, the key W, so that's what capital K underscore is a shorthand for saying the keyboard W is pressed, and P1Y, remember P1Y is the player value that we defined on the y-axis. It's going to spawn at 250. If this value is greater than 0, colon, this is what we're going to do. We're going to say, take this value of P1y and we're going to move it down by 5 pixels. In order to automatically update this value, currently the value is set to 250. We're just going to say minus equals 5. So that if player 1, and we've already gone ahead and decided that player 1 is going to use W and S. Player 2 will use up arrow and down arrow on the keyboard. So if player 1 hits the W key and player 1's position is greater than 0, we're going to move player 1's position down by 5. Great. Now we need to chain this if statement into an else if statement. So if this case is not true, we're going to say keys, brackets, capital K, underscore, S. So this is saying, and P1y plus, remember this variable is going to come into play now, paddle height. Is less than the screen height. We're going to move P1y, you guessed it, up 5. To move it up 5, we're going to say, instead of minus equals, plus equals 5. So what's happening here is basically we wrote logic. I know this logic doesn't make a whole lot of logical sense, but it does. We just need to visualize what this code is doing in order for it to make sense. If the W key is pressed and the top of player 1's paddle is above the screen, the paddle will move up. If the S key is pressed, however, and the bottom of the paddle is below the screen, the paddle will move down. We're about to write the same exact logic for player 2, only instead of using W and S, we're going to use the arrow keys. We can say this is paddle movement for player 1, and then we can say this is paddle movement for player 2. We just want to make sure we're still chained in this if-else chain. Luckily, we've already defined keys equals key dot get pressed because no one wants to be pressed in this moment. Say if keys bracket keyboard input up and player 2's Y is less than 0, colon, and move player 2's Y position down 5. Minus equals 5. Else if keys brackets keyboard input underscore down and player 2's Y position as well as player 2's paddle height is less than, you got it, screen height, colon, let's move player 2's Y position up 5 equals 5. You may notice that we're saying let's move up to move down and down to move up. This is kind of backwards, isn't it? We can visualize this later and understand how that works in the code once this thing is actually running. So the player 2 paddle movement and the player 1 paddle movement has been defined within the while loop. That's awesome. Now, we need to handle ball player collision. Remember, we're still going to be in this for loop. So we're going to enter down here and we're going to backspace 1 so that we're in line with the for. What we defined up here all those years ago. P1 paddle, P2 paddle, and ball. These are objects that we set in motion that we haven't even defined yet, but we're finally defining them. Right here, right now. We're doing this in the while loop so that it can be constantly updated. So we're going to define player 1 paddle and player 2 paddle. Cool. Looks like it took us back into this if statement. We don't want to be there, so let's backspace to be still in our for loop. Okay. P1 paddle equals. This is going to be a rect object. And this is going to take a couple of parameters. First, we're going to set this to 50. Player 1 Y. And we're going to input paddle width and paddle height. Okay, player 1 paddle has been defined. Scroll back up to here, we can see that this in our draw objects function has finally gotten defined. We've plugged it into this. What this does is it takes a couple of variables. First, it's going to take the variable of P1. P1Y is the Y position right here. Player value, which is 250. It's also going to take the width and the height. We defined paddle width and paddle height right here under player values, where paddle width was 30 and paddle height was 100. 50 is going to set this to the side of the screen where it's at 50, because this is player 1. It's going to, from the screen, it's going to be set at 50. So that means it's going to be on this side of the screen. While player 2 is going to be set on the opposite side of the screen. The opposite side of the screen is going to be around 850. That's 850 over, which is going to be around here on this side of the screen. So P2 paddle is also going to be a rect object, but instead of 50, it's going to be 850. That's where it's going to spawn in. P2Y. This is the Y position of player 2. We're also going to enter paddle width and paddle height. Lowercase p. Okay, cool. We're defining both of these paddles for both player 1 and player 2 as rect objects. Rectangular objects. These rectangular objects take in a number of parameters. So we've gone and defined our paddles. There's one more thing that we need to define. That's the ball. We haven't defined the ball yet, but we're about to, so don't you worry. This is going to be hashtag ball. position. First, we're going to actually define what ball is. So we'll set ball equal to, yet again, another rect object. I know earlier we set the ball equal to an ellipse. Earlier we said draw.ellipse. We did indeed say draw.ellipse instead of draw.rect. But this is going to be slightly different than how we're defining it. So we're saying draw specifically. So instead of drawing a rectangle, it's going to be drawing an ellipse, and it's going to take in these parameters, including the variable ball, which we're defining right now. However, ball is still going to be a rect object, because rect objects are different than rectangles. That makes perfect sense, right, everyone? Cool. So this is a rect object, just like the paddles. And we're going to say this object, let's say, it's going to have a couple of parameters as well. Now we've already defined what the x and y are going to be for the ball, right? Actually, we haven't, but that's the two parameters that it's going to take in. Because the x and y value is constantly going to be updating for the ball, if you remember what's happening in defining the ball's motion, it has a speed of 4. This is when this is going to come into play here, right here in the ball position. Okay, so let's go back to our rect object. Our rect object is going to go ahead and take in these variables. It's going to take in ball x and y. These are the coordinates that the ball is going to spawn. It's going to be 450x, 300y. So that exact is going to be ball x, comma, ball y. Oh no, you've sunk my battleship right there in the middle of the screen. As 10, 10. Why are we saying 10, 10? Where 10, 10 is going to be the boundary of the ball. So while the ball is bouncing around, it's just going to be in a 10 by 10 pixel range. We've defined the ball. Perfect. Let's update the position. So, ball x. Ball x is the ball's motion that we're defining here of 450. This is going to plus equal, you guessed it, to dx. Ball dx, that is. Then we're going to take ball y, and that is going to plus equal to ball dy. This is the x and y position that we defined right up here. So this is going to say, we'll move this x plus 4 and this y plus 4 continually and internally for the rest of existence. And what this is going to do, it's going to make the ball float across the screen. Kind of like a keyframe, if you're familiar with animation at all, but essentially that's what we're doing right now. We're animating the ball. Okay. We've defined the ball's position and how it's going to update. In programming terms, this would be called an iteration. This next segment of code is going to be an epic player collision detection segment. Alright, so if ball dot collide rect with player 1's paddle, we're going to do this if this happens. Now, what is ball.collide rect? Well, this is yet another method that we just created, because collide rect is going to check for collisions between the ball and the paddles. If the ball collides with player 1's paddle, its horizontal direction, or ball dx, is going to be reversed. And if it collides with player 2's paddle, the direction will be reversed, but with a negative value. If player 1's paddle collides with the ball, we're going to do this. Yeah, we're going to change ball dx to equal. Whenever something is equaling something like this, it automatically becomes a Boolean variable. Boolean variables are true, or they are false, or they create some sort of output that is true or false. In this case, we're going to use absolute value. Absolute value is very much a Boolean statement. Absolute value is abbreviated with ABS, and it's going to womp to ball dx. If you remember from high school algebra class, when you take the absolute value of something, it's always the positive integer, never the negative one, because this value that we're dealing with, ball dx, is only going to be dealing in the positive x-axis, horizontal direction. When people say math and programming don't really overlap, I mean, they don't really, but in games and linear algebra, yes, they kind of do. Ball dx is equal to the absolute value of ball dx. Elif ball dot collide rect this collides with player 2 paddle. However, we're going to do this. We're going to say ball dx equals the absolute value of ball dx. We're going to multiply this by -1. When we multiply anything by -1, what it does is it makes it negative. It means it's going to move in the opposite direction. So we're taking ball dx if it collides with player 2's paddle. Remember, player 2's paddle is going to be on this side of the screen. So when the ball collides with this paddle, it's going to shoot off this way to the left. If it collides with player 1 paddle, it's going to shoot off this way to the right. That's all we're doing here. We've dealt with what will happen if the ball hits the player's paddle. But what will happen if the ball hits the wall? There's going to be a top wall, there's going to be a bottom wall, there's going to be a side wall, another side wall. These two side walls, if the ball passes there, well, we're going to score a point. But what happens if it hits the screen height or something like that? What happens then? It bounces off of it instead of going through it. So this is going to be called what happens when the ball hits the top or the bottom of the screen? Question mark, exclamation point. We're going to say Elif. Cool. This is going to take a couple of variables. We're going to say ball y. And remember ball y. What is ball y? Well, look right up here to the ball's motion. Ball y is right here. But ball y is also constantly being updated by this ball position method. Whoa, there's so much going on right now. But it's okay. Because essentially, if ball y is less than or equal to 0, or essentially if ball y is less than or equal to 0, that means that it's at the bottom of the screen. The bottom of the screen is going to be this border right here. Or ball y is greater than or equal to the screen height. So what exactly does this mean again? Right, good question. If the ball collides with player 1's paddle, it's going to shoot off to the right. If the ball collides with player 2's paddle, it's going to shoot off to the left. If none of this happens, and it hits either the top or the bottom of the screen, well, it's going to math. And the math that it's going to do is going to take ball dy, and that's going to be equal to the negative of ball dy. What's ball dy? Ball dy is this right up here. That motion of 4 on the y-axis. If it touches the top or the bottom of the screen, the vertical direction, which is ball dy, it might help if we annotate that, by the way. Wompity bompity dump. Vertical direction. And this is the horizontal direction. You can call this direction, you can also call this speed, because speed is just distance over time. This is the ball, the cursor is the ball. So the ball is coming down, the ball hits 0. It hits 0, so the vertical direction of the ball is instantly inverted. The vertical direction, remember, is 4. So it's going to be inverted. And once it's inverted, it's going to go flying in the opposite direction. And if it hits the screen height, it's also going to be inverted, and it's going to go flying in the opposite direction. Now we need to update the score, as well as reset the ball if either player wins or earns a point. And remember, we're still going to be in this fun little if-else chain. So this is what happens. When someone scores and how is the ball reset? Okay, well, that's a great question. Elif. It doesn't interact with player 1 paddle, doesn't interact with player 2 paddle, and it does not interact with the top or the bottom of the screen. If all of these happen, then this is going to run. Because if all of these happen, that means someone scored. I'm going to say ball x is going to be greater than or equal to screen width or ball x is less than or equal to 0. If the ball hits the right or the left side of the wall, the score must be updated. Well, remember that player 1 is playing here on the left side of the screen. So if the horizontal position or the x position of the ball is greater than or equal to the screen width. And what is screen width? Screen width is a set constant that we defined earlier as 900. So if this position exceeds or equals 900, that means player 1 has scored a point. If the x position of the ball hits or goes past the 0 position, that means player 2 has scored a point. If ball x, the x position of the ball, greater than or equal to screen width, colon, we're going to update player 1's point value by 1, which means P1 points plus equals 1. That means every time this happens, player 1 is going to get 1 point. If this does not happen, elif ball x is less than or equal to 0. What does that mean? That means that player 2 has scored. So we're going to say colon p2 points plus equals 1. Okay, this logic makes perfect sense because whenever someone scores a point, we're going to want the x and the y position of the ball to reset back to the middle of the screen. So let's say ball x equals 450 and ball y equals 300. And what this does is resets ball position back to the middle. Nice. Then we can remove this space just so it's clear on what is happening there under that elif chain. Now all we need to do is draw in some game elements. Okay, let's draw in these elements of the game. Now remember, we're still going to be under this for loop, so let's hit 1 backspace. And we're going to draw the game elements. Now what exactly are the game elements? Well, the game elements are going to be exactly what we defined all the way up here in our very first function of draw objects. This is going to draw everything to the screen. And we want this inside of the for loop so that these variables can constantly be updated by this logic chain that we've made. We're going to say screen dot fill. This method is simply going to fill the screen with our selected background color. Remember the background color we selected earlier was black. Then we're going to call the function that we made, which is draw underscore objects. In order to call a function, we need these parentheses. That means the function has indeed been called. It's going to draw the rect for the paddles. It's going to draw the ellipse for the ball. Wonderful. Okay. Now we just need to render and display the score onto the screen. This is going to be part of the game elements. So let's display score. Okay, to display the score, we're going to go ahead and make a text variable. This is going to be called p1 pts txt. You can also name this whatever you like, as long as it's equal to Comic Sans 35 or your chosen font. Okay, in this we're going to call another method called .render. Nice. This is built into Pygame. Okay, and what's it going to say? In Comic Sans, we're going to render to the screen p1 points, or whatever you'd like. Put a colon, space, and we're going to add something to this. We're going to say plus string, the variable that we've created called p1 points. This is that point value that we have right up here, that what happens when someone scores, called p1 points. It's going to add 1 point to the p1 variable. And where is the p1 points variable? Well, it's right up here on the player values. p1 points. Both of them are going to be initially set to 0. So that's what's going to be displayed onto the screen. And whenever it runs through that code and it updates, it's going to say 1, 2, 3. Now it needs this method needs one more thing. We want to set it to true. This just tells it that this is a true variable and we do want it. And then we're also going to input the color for player 1 because we want our colors to be color coded because that's visually appealing. Okay, that's player 1 color. Now we need to do the exact same thing for player 2. We're at a point now where we can simply copy and paste, the crux of programming. So let's go ahead and Control C and Control V. Now we need to change everything where it says player 1 to player 2. So player 2 points, player 2 points, and player 2 color. Nice. Now we've rendered it into the function, but we haven't actually displayed it onto the screen yet. That's because Pygame uses yet another method in order to display it on the screen. To do that, it's called .blit. So we're going to say screen.blit. And then we're going to take our player 1 points text variable, and we're going to say exactly where we want this to be inputted. So we need to put these XY coordinates in their own set of parentheses. We're going to put them at 130, 20. And then we're going to do the same thing for player 2 text variable, which is player 2 points txt, and we're going to put that at around 620, 20. Great. So that'll be at the x position of 130 and the y position of 20, and the x position of 620 and the y position of 20. All right, we've displayed the score. Now, we only have one more thing to do, and that is update the display and the frame control. Updating the display is exactly what animates everything on your screen. It's what's constantly drawing. Updating the screen. To do that, we're going to run two commands. One's display dot flip. This is yet another method that just says let's constantly paint these pixels. My clock, you remember that from way long ago, dot tick is going to have a tick rate of 60 or 60 frames a second. And well, guys, that's actually it. You've created Pong. Good job. Now all we need to do is press enter again, press backspace, press quit. Quit is yet another method, and to call a method or a function, we always need these parentheses. Boom. We're just going to press this play button. This is going to run the Python file, and you may have to press it again. This is cool. Like, what's happening? The ball's spawning in the middle. We got blue and red, and if we move the up arrow and the down arrow, the ball seems to collide, and the ball's colliding with the wall. Oh my gosh, you guys, but honestly, this is my fault for being silly. Press X, it's going to stop the code. When we rendered the to the screen, it kind of messed up the variable there. So this placement is likely going to look a whole lot better. And actually, I want to move layer 1 over just a little bit, make it a little bit more centered. Cool. How do we do that? 80. No. 70. Yes. Okay, great. Yeah, that looks more placed. This Pong game can be improved vastly. So we're obviously going to be improving upon this Pong game by making the ball go faster, having some more fun things that we can do, but this is the base code of Pong. And the fact that we've coded the base code of Pong that someone figured out who was super smart long time ago, that's crazy. But we're getting there. And learning to code, it's super fun. And it's something that we can keep doing right here on the Charcode channel.